Hello everyone. In this lecture I shall discuss the applications of first order linear ordinary differential equations. There are several applications of first order linear differential equations such as Newton's law of cooling, radioactive growth, radioactive decay, electric circuits, etc. In this lecture we shall discuss the Newton's law of cooling. So before the details of discussion, let me to introduce myself. Myself, Professor Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. So now without much delay, let us discuss the Newton's law of cooling. Now coming to the Newton's law of cooling, it states that under certain ideal conditions, the rate of loss of temperature of the body, suppose the temperature of the body I say T, okay, is proportional to the difference between the temperature of the body and the temperature of the surroundings. Suppose I take the temperature of the surroundings is T1. Then according to the statement, dt by dt is proportional to the difference of the temperature of the body and the temperature of the surroundings. Okay, so this is the statement here, mathematical representation of this. Now, so this implies here dt by dt, since we are talking about the loss of temperature, okay, I multiply the constant of proportionality here. A negative sign is here because of the loss. It is k times t minus t1. K times t minus t1. So here k is positive, and here negative sign indicates with increase in t, when time increases, your temperature decreases. With increase in time, right? With increase in time, the temperature decreases. Okay. So as I have told, T is the temperature of the body, T1 is the temperature of the surroundings, and K is the constant of proportion. K is positive. Negative sign indicates that temperature decreases with increase in time. So now our job is to solve this differential equation. Okay. This is a first order linear differential equation and we solve it. We use the variable separation method. So let this be my equation 1, say. On solving equation 1 by variable separation method, we get, you see here, dt, bringing this to this side here, dt divided by t minus t1 is minus k times dt. If you integrate both sides, t1 is constant here, it is ln t minus t1 is minus k, integral of dt is t plus some constant I write, suppose ln c. Okay, now bringing this to this side, so that means ln a minus ln b, ln t minus t1 by c is equal to minus of kt. So this implies removing ln by taking exponential, t minus t1 by c is e to the power minus kt. So now this implies t minus t1 is c e to the power minus kt. So this implies t is equal to here t1 plus c e to the power minus kt. Okay, so we may remember it, that after simplification of Newton's law of cooling, we will get a result like this. So for while we solve a problem, we may come directly to this. Okay, t is equal to t1 plus c e to the power minus kt. So now let us solve some problems on this basis. So now the example is like this. A copper ball is heated to 100 degrees centigrade. Means initially the temperature of the copper ball is 100 degree. This is my T of 0. Then at time T is equal to 0, initially it was 100 degree centigrade. It is placed in water, which is maintained at 30 degree centigrade. Okay, so the temperature of the surrounding here is 30 degree centigrade. At the end of 3 minutes, after 3 minutes, the temperature of the ball is dropped to 70 degree centigrade. Gradually it will decrease because the surrounding is 30 degree centigrade. So we have to find the time, okay, at which the temperature of the ball is reduced to 31 degree centigrade. So if you analyze the question, right, initial temperature in the ball is 100 degree centigrade and the temperature of the surrounding here is 30 degree centigrade. Okay, so after 3 minutes the temperature is dropped because surrounding temperature is less. It is dropped to 70 degree centigrade. So what we are asked? We are asked at what time T of what is 31 degree centigrade. Okay, 31 degree centigrade. So we have to find this. T of T is equal to 31 degree centigrade. So now what is that T? So this need to be obtained. So this is the analysis of the question. So as usual, by Newton's law of cooling, we will come to this step. T is equal to T1 plus Ce to the power minus Kt. Okay, or we may simplify it to get it, and or we directly write it. So let us follow the following steps. We have, by Newton's law of cooling, dt by dt is minus k times t minus t1. So that means dt by t minus t1 is minus k dt. Okay, so this implies ln t minus t1 is minus kt plus ln c. So this implies, if you simplify it to get t is equal to t1 plus ce to the power minus kt. Okay, so the value of t1 is known. So that means here t is equal to t1 is 30 plus ce to the power minus kt. Okay, now we impose the conditions. Let it be my equation 1, let it be my equation 2. Now we impose the conditions. So coming to the first condition, you have T of 0 is 100 degrees. So you see here we have two things to be determined. Okay, one is the constant C, other one is the constant K here, proportionality constant, and it is the constant, arbitrary constant here. So now we have two conditions, condition T of 0 and it is T of 3. Using these two conditions we have to find this value of C and K. So let us impose these conditions. So T of 0 is equal to 100. What does it mean? When small t time is 0, here capital T is 100. So you substitute it. So this implies my 100 is equal to 30 plus C e to the power 0 is 1. So this implies here C is 70. Okay, C is 70. So you substitute it here. So that means here T is equal to 30 plus 70 e to the power minus kt. Okay, next you substitute the second condition. Here T of 3 is equal to 70. Right. So what does it mean? When T is equal to small t 0, capital T is 70. So you substitute it over here. So here 70 is equal to, sorry, T is 3. 70 is equal to 30 plus 70 e to the power minus 3k. So let you simplify to get the value of k. So here we need to simplify to get the value of k. So bringing this to this side is 40 is equal to 70 e to the power minus 3k. So this implies e to the power minus 3k is 4 by 7. Okay. So now removing this exponential, we have to take the log to both sides. So minus 3k is equal to ln 4 by 7. Okay, so this is ln 4 minus ln 7. So removing the negative sign, here 3k is equal to ln 7 minus ln 4. Okay, so this implies here k is equal to, if you simplify it, this value will be 0.1862. Right, now you substitute this value of k here. You substitute the value of k here. Okay, this value of k, you substitute it here. So this implies, so therefore here capital T is 70 e to the power minus 0.1862 t plus 30. We just simply substitute it here. Okay, we simply just substitute it here. So now coming to the last aspect of this. Now coming to the last aspect of this question, that at what time it is 31 degrees centigrade. Okay, so now we impose it to get the value of t. Here we need to find the value of t. So now coming to the last aspect, t of t is equal to 31. Right, so implies we need to find what is the value of t. Right, so here 31 is equal to, substitute it, 31 is equal to 70 e to the power minus 0.1862 t plus 30. So bring it to this side. So this implies here 70 e to the power minus 0.1862 t is here 30 minus 31 minus 30 is here 1. So that means e to the power minus 0.1862 t is here 1 by 70. So now removing this exponential, we have to take the log. So minus 0.1862 t is here ln 1 by 70. Okay, ln 1 minus ln 70. Here ln 1 is 0, so multiplying a negative sign. So here 0.1862 t is ln 70. So this implies here t is equal to ln 70 divided by 0.1862. So this is, if you simplify it using your calculator, you will get it 22.7, or which is 22.7, which is approximately same as 23 seconds. Okay, so this is your answer at 23 seconds. So minute here, the unit is minute. We have taken 23 minutes because 3 minutes later the unit is here is in minutes. So the answer is after 23 minutes the temperature will drop down to 31 degrees centigrade. So therefore hence after 23 minutes the temperature of the ball decreases to 31 degrees centigrade. Okay, coming to one more example. Now coming to another example, a substance cools from 100 degrees centigrade to 80 degrees centigrade in 10 minutes, whose surrounding temperature is 25 degrees centigrade. So this is my T1. Find the temperature of this substance after 20 minutes, means T of 20 is what? And find the time. We have to find T when the temperature of the substance is 40 degrees centigrade. Okay, so if you analyze the problem, a substance cools from, means initially it was T1, T of 0, the initial temperature here is 100, right? 10 minutes later, after 10 minutes, T of 10, okay, it decreased to 80 degrees centigrade, is here 80 degree centigrade. And the temperature of the surroundings here, the temperature of the surrounding here is here 25. And what you are asked? You are asked to find what is the temperature after 20 minutes. Then next it is asked T of what? At what time the temperature of the substance is 40 degrees centigrade. Okay, so it is likewise the previous problem. If you solve it, coming to the solution, so okay, let T1 be the temperature of the surroundings. We have, by Newton's law of cooling, dt by dt is minus k times T minus T1. Okay, so if you simplify it, so this implies here dt by T minus T1 is minus k times dt. If you integrate both sides, and you will get it, T is equal to T1 plus C e to the power minus kt. Okay, so now impose the conditions. T of 0 is equal to 100. So you substitute it. Okay, so here 100 is equal to the value of T1. T1 is 25. This is here 25 plus here C. So this implies here C is equal to 75. So this is the value of C. If you substitute it here, then therefore here T is equal to 25 plus 75 e to the power minus kt. Now you impose the second condition. The second condition is T of 10 is equal to 80. So again T of 10 is equal to here 80. Okay, so that means here capital T is here 80, small t is 10, right? Small t is it is 25 plus 75 e to the power minus 10k. Now here we have to solve what is the value of k now. Okay, if you simplify it, so that means 70 e to the power minus 10k is 80 minus 25. 80 minus 25 is here 55. So that means e to the power minus 10k is here 55 by 75. So removing exponential, here minus of 10k is taking log 55 minus ln 75. Or we may do one thing. Instead of k, we find suppose e to the power minus k. Okay, what is the value of e to the power minus k? Then the calculation will simpler here. So this implies here e to the power. So this implies here e to the power minus k will be 55 by 75 to the power 1 by 10. Now we substitute this value. We substitute this value here. Right? We substitute this value here. So therefore here t is equal to 25 plus 75 into the value of e to the power minus k is here we substitute into here 55 by 75 to the power t by 10. Okay, to the power here t by 10. Now next it is asked t of 20 is what? So we find t of 20. Now t of 20 is equal to, after 20 minutes, right, after 20 minutes t of 20 will be here, we just substitute t is equal to 20 here is 25 plus 75 whole into 55 by 75 to the power 20 by 10 means square. Okay, if you simplify it, it will give you 65.33 degrees centigrade. Okay, so this is your t of 20. Now coming to the last part, t of what is equal to here 40 degrees centigrade. Okay, 40. So we have to find that. Now coming to this, here 40 is equal to 25 plus 75 into 55 by 75 to the power t by 10. If you simplify it, so that means 75 into 55 by 75 to the power t by 10 is this minus this is 15. Okay, so that means 55 by 75 to the power t by 10 is here 15 by 75. Now we take log to both sides. Okay, so this implies here t by 10 ln 55 by 75 is ln 15 by 75, right? So this implies here t by 10 is ln 15 by 75 divided by ln 55 by 75. Okay, so this means here t is equal to 10 into this ln 15 by 75 by ln 55 by 75. If you simplify it, it will give you 51.89 minute, and which is approximately 52 minutes. Okay, so 52 minutes. So this is your answer. Okay, so we are asked two things: t of what is 40, so we get t, that t is here 52 minutes, and one more thing, what will be the temperature after 20 minutes. So these are the two aspects we obtained. To conclude, we have one more assignment problem. A thermometer reading is 15 degrees centigrade. It brought to a room whose temperature is 23 degrees centigrade. This is your T1. Okay, and this is your T0. Initially the reading is 15 degrees centigrade. 1 minute later the temperature dropped down to 90 degrees centigrade. This is T of 1. How long does it take? Means how long does it take? T of what is equal to 23. Okay, and we have to find what is your T. So you should solve it in this similar pattern. Now we should close this lecture, and in our upcoming lecture we will discuss the radioactive exponential growth and decay. Okay, exponential growth and decay. Such type of problems we will discuss. So now at this stage I must request to all of you that if this lecture is useful and interesting to you, please like and subscribe to this channel, which will boost my motivation to upload the subsequent lectures for your benefits. So let us close this lecture here. Thank you all. Have a nice day.